Let's have a look at some other more examples of constants. And we've got some here for floating point values. And we've also got constants that we can use for characters. So capital A, that will stand in for the 65 in the ASCII numerical system. And you have lowercase a, and so on and so on. And an interesting one that's here is called the terminating null value. Now, why does it actually terminate? It's used to terminate strings. And I'll show you why that's necessary. Let's say you're writing your code in your program and you're creating a string, or what we can also call string literal. You start with a quotation mark, you write hello, exclamation mark, quotation mark, and when that actually gets stored in memory, it will get stored as a sequence of 7 bytes. Now you might be wondering, why do we need 7 bytes instead of 6? Because we actually only have 6 characters. And that is because the characters themselves are stored in an array, or you can think of it for now as a list of items. And the program needs to know when that list eventually ends, essentially. And that's why it adds in a terminating null character. It's not something that you will need to worry about when you're creating a string, but you just have to be aware of it being stored in the actual representation of that string, essentially. So it gets added on in the end of that string. Now, what if we wanted to, let's say, add an additional quotation mark in here? Let's say we wanted to output this hello message, this hello string, in quotation marks, right? Because we need quotation marks to create the string, so they don't actually get output in that string. But what if we wanted to have those quotation marks as part of the string, right? Then it gets a bit tricky. And we have something for that called escape sequences. And these are special characters that stand in for other values that you can use in your strings without confusing the compiler. Because if you really think about it, let's go back to that example. If you, for example, put in here a quotation mark, a second quotation mark, the compiler is going to think that there's no string, the string is done. If you put it here, if you put the second quotation mark here before this one, then the string will end early and you'll be left with another quotation mark outside with no match to follow. So the compiler will have no idea what you're doing with that second quotation mark. And that's how we get around that. We use escape sequences. For example, for the quotation mark, we have backslash quotation mark, and that's going to give us that double quote there. So they normally start with a backslash. You don't need to remember or memorize all of them. The ones that you use commonly, you will automatically memorize, or you can always look them up. But let's see how they can actually get used in the program. So we start here with our preprocessor for inputting, outputting into the console log. We have the standard namespace, and then our main function that will run our code. We start out with cout, so we're outputting to the console, and we right away we have a string, but it looks quite robotic. It looks quite odd if you first look at it without being aware of escape sequences. But let's break it down. It starts out with \n, and \n is the escape sequence, if you look at the table, for a line break. So it's an alternative to using and L as we had seen in the previous programs. So we start with a line break, then we have this is, and then \t, and that stands in for a horizontal tab, which is what we have here. A string \n, so the line break, and then \t, so we have 2 tabs, which gets us lined up really nicely here. And then with backslash quotation mark many backslash quotation mark. So this is what gets the quotes in here. Escape sequences and then backslash n, and that's another line break, which obviously we can't see because it's invisible. And then return 0.